Alrighty, so let's talk really briefly about binomial special products. And just for a second, let's just talk about what I just said. Binomial, right? We know that that is a polynomial that has two terms, so something plus or minus something, right? So it's two pieces. Special, we all know what special means, right? Unique or different. And then products, that's the answer to a multiplication problem, right? So we are talking about unique cases where something has been multiplied and that something has been multiplied is a binomial, okay? So we only have two of them. We only have two special cases, and really this is more of just a lesson on shortcuts, just ways that you can kind of beat the system and go quicker than really distributing out the whole problem. And you'll see what I mean in just a second. So let's just look at the top of your paper. It says consider squaring a binomial. Okay, so we've got x minus 4 squared. We've done these problems before. I told you that you cannot distribute the square, and I still hold to that. But let's try actually doing it the long way, right? X minus 4 times x minus 4. If we distribute it out, x times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. And negative 4 times negative 4 is positive 16. If I combine like terms, that would just be these two x's. So I've got x squared minus 8x plus 16. Okay, kind of think on that for a second. Let's try the other one. 2n plus 3 squared. Again, these are both binomials because I have two pieces inside and they're being squared. They're being multiplied times themselves. So I'm going to write it out again the long way. You should be able to do this part by yourself, by the way. So if you just want to work ahead of me, you'll probably go faster than I'm going. 2n times 2n is 4n squared. 2n times 3 is 6n. 3 times 2n is 6n again. And 3 times 3 is 9. So we've got 4n squared plus 12n plus 9. Okay? So what we want to do now is we want to pause and see if we noticed any patterns or shortcuts we could take or ways that these two problems are similar. Because we are squaring it, you can kind of go ahead and look and see, well, I'm eventually going to multiply this 4 times itself. It's 4. I'm going to multiply this 3 times itself, right? And you can see that in your answers. I have 4 times 4 is 16 right there. 3 times 3 is 9 right there. Same with my first term. I'm going to square the 2n, so 2n times 2n is 4n squared. And this x times x is x squared. But we have to think about this middle term. That's kind of what we forget whenever we try to distribute the square. So that middle term, think about how we got that. Well, on the left-hand side, it was the result of 4x and 4x put together, right? Over here, it was the result of 6n and 6n put together. Well, how did we get that 4x or that 6n? Well, we multiplied these two things times each other, right? If this is kind of blowing your mind right now, don't worry about it. I forgot to say at the beginning, again, because this is kind of a lesson on just shortcuts, if you want to do it this long way with the arrows every single time, please do so. I am required to show you the shortcut, but you really don't need it whatsoever. Okay, so let's get back to what I was saying. What we just saw is that this special type of multiplication problem results in something called a perfect square trinomial. So back on your notes, it says squaring a binomial results in a special product called a perfect square trinomial. Okay, and again, let's just break that down a little bit. Perfect square. Ooh, I don't want to do that. Just the term, just the term perfect square trinomial, just the term perfect square, sorry. We know that the perfect squares are 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 16, 25, etc., right? Well, we see those at the ends of our problem, right? X squared is the result of x times x. 16 is the result of 4 times 4. Over here we've got 4, we've got 9, okay? So perfect square is referring to the ends of our answer. Trinomial, we know what a trinomial is, that's just a 3-piece polynomial. But again, if you look up at these problems, we have 1, 2, 3 pieces. 1, 2, 3 pieces. So a perfect square trinomial is really identified by the perfect squares in the first and last terms, and then the middle term is a little bit different, which I'll show you on this next slide. So this goes in the blanks underneath what we just wrote down. So a plus b squared. Anytime you have something that is in the form of something plus something and it's being squared, your answer is going to look like this. Okay, and this is what goes in that blank on your notes. You're going to take the first term. Okay, so over here it's just shown by an a. Normally it's going to be an x or 2x or 5x or something, and it's going to be squared. Whatever it is, you square it and you write that first. Okay, At the end, you're going to take the second term, in this case a b, and square it. That's the easy part. You just take the two pieces and square them, just like you were distributing that square. Okay? Same with if it was a minus b squared, it's the exact same. A squared goes in the front, b squared goes in the back. Okay, and we'll work this out here in a second. The middle term, however, is the part that is kind of weird. You'll notice it doesn't have a square anywhere. It has a 2, a big old 2, right? A coefficient of 2. So we're going to double, multiply times 2, a times b. Okay? And a and b, again, are the two pieces of your problem. So let's just try this out with these problems down here. Okay? We have x plus 8 squared. Well, if I think about what I was just talking about, this is like our a, and this is like our b. Okay? So the first part of my problem would be to take these two pieces and square them and put them on the ends, right? So I've got x squared at the beginning, 8 squared at the end, in this case 64. It's the middle term that's kind of weird, right? So I need to put these two pieces together, right? Looking up here, 2ab, I need to put them together, so a times b, so in this case 8x, and then I double it, so that would be 16x, okay? Now let's see this broken out a little bit more. Let me move this pink square. Okay, so like I said, we have the first term squared here, the second term squared at the end, and in the middle, we've got 2 times a and b put together, okay? But if we actually work all this out, x squared is x squared, 2 times 8x, that is 16x, and 8 squared is 64, okay? So it matches with what we came up with over there on the side. So let's try the next one. Exact same thing, okay? To get the first part, I'm going to square the first part. So 3x squared, that'd be 9x squared. Okay, to get the last part of my trinomial, I square the last part. Well, negative 5 squared is just 25. Okay, now we didn't talk about signs on this top one, like plus or minus, but I'll go into that in just a second. And then to get the middle term, I multiply these two together. Multiply, right? So 5 times 3x would be 15x, and then I double it, and I get 30x. Okay, so let's see that kind of broken down underneath this rectangle. So this one's a lot longer. Take the first term and you square it. That's what they're showing here. The last term and you square it. That's what they're showing here. And then on the inside, they're showing 2, and then a and b put together, multiplied. Okay, and again, when you actually multiply all that out, you get what we had, 9x squared minus 30x plus 25. Now, the one thing I haven't talked about, like I said, was the positive and the negative. So we have two different forms up here. Let me switch my colors so you can see what I'm talking about. Up here, we have two different types, and the only difference between them is that this is a plus b squared and this is a minus b squared, okay? If you look at our answers, the only difference is here and here, right? And really that just comes from, if you're going to square something, whether it's positive or negative, it's going to be positive. So that makes this a positive and this a positive. And really this a positive and this a positive. The only difference comes that if you have a negative here, it's going to pop up when you start multiplying, and it's going to be negative in front of your second term. Okay, so you can just kind of always stick those in. Like if I was to go back to the problems we were doing, I'd go ahead and write plus signs here and here, because that's a given. And then I look at the middle, it's a plus sign, so that's a plus sign. That's a minus, so that's a minus. Okay? Alrighty, so if we look at two practice problems, instead of multiplying this out the long way, which we could do, and let me again go ahead and reiterate, if you have no clue what I just talked about for the last 8 minutes, you can just multiply these out like normal. Just make sure you write them twice and then distribute everything. But if we wanted to go ahead and try the shortcut, I know that to get my first piece, and again, feel free to pause it right now and try it on your own. You don't have to listen to me talk through it if you feel like you want to give it a shot. Just pause and start working and then turn it back on and see how you get. So for my first term, I need to square this. Okay, so I've got 4x squared. For my last term, I need to square that, 64. For the middle term, I need to multiply these together and then double it. Okay, so 8 times 2x, that's 16x, doubled is 32x. And then my signs, every time I can put a plus sign here, and then I look to my sign in the middle minus for this sign. And that would be our answer. Okay, so let me try this one over here. Again, I square the first piece, so that's 64x squared. I square the last piece, that's 16. And then to get my middle term, I multiply these together, so that's 32x. and then I double it, and I get 64x. For my signs, this is always a plus, and then I use this one for right there. Okay? Now, let me remind you, this only works when you are squaring a binomial. For example, if I did 2x squared plus 3x plus 9 and I squared it, this ain't gonna work, okay? Because that's a trinomial, right? If I did 2x and I squared it, not gonna work. This is a monomial, okay? If I can't think of another example. Just don't apply this to everything. I don't want you to start just squaring like crazy and doubling. It only works if you have a binomial that you are squaring, okay? Alrighty, so we have one more special product. This is kind of the bottom part of your notes page here. These are also special products because we're multiplying a binomial times itself, except for the sign is going to change. Alrighty, so let's work out this first one. I've got 3x times 3x, it's 9x squared. 3x times 4, that's 12x. Negative 4 times 3x, that's negative 12x. And negative 4 times 4, which is negative 16. So I'm going to combine like terms here. So 9x squared, these are going to cancel each other out here and here. So I've just got minus 16. Okay. Looking over here at the right, 2y times 2y is 4y squared. 2y times negative 8 is negative 16y. 8 times 2y is positive 16y. And 8 times negative 8 is negative 64. Combine like terms, so I've got 4y squared. What do you know? Again, these cancel, minus 64. Okay, so again, if we kind of look at this and try to notice any patterns, obviously these are both similar because those x's and the y's canceled out, right? We were only left with our first and last term. So it didn't even result in a trinomial, it resulted in another binomial, okay? So this is something that we call, let me scroll down, a difference of two squares, okay? And again, if I kind of dissect this a little bit, a difference, as in subtraction, right? If you look at my two answers up there, you'll see they're both subtraction. That is no coincidence. And then of two squares, honestly, if I was to make this a little bit better, I would say a difference of two perfect squares, but, you know, whatever. So we have two perfect squares here. 4y squared, 64, they're being subtracted. It's a difference. 9x squared and 16, they're being subtracted, two perfect squares. So that's where the name comes from, a difference of two squares. Okay, and that's what goes on your notes. These problems result in a special product called a difference of two squares. So, again, two different types here. I tried to make it very distinct by putting that dotted line box around both of them so you could tell. But this bottom one starts with a long problem. Okay, you see 3x minus 4 times 3x plus 4. And it results in this short, tiny little two-piece answer. Okay, again, here's my long problem, 2y plus 8, 2y minus 8, and it results in this short answer. What we had before was a short problem, right? It's just something squared, and it results in the trinomial, the long answer. Short problem, but then the long answer, okay? So they're kind of like opposites of each other. Not necessarily like mathematical opposites or anything like that. They just produce their opposite. One is short, becomes long. One is long, becomes short. Okay, so let's talk a little bit more about a difference of two squares. So this is what it looks like every time. You have something plus something times those same things, but with a subtraction sign. Okay, and those two signs can be out of order. It can be plus and then minus, or minus and plus, doesn't matter. Now, your answer is simply the first thing squared minus the second thing squared. So this one's a little bit easier in that you don't have to double anything. You just take the first one squared, take the second one squared, and put a minus sign. Okay, so looking at these examples, I have to pause it here, I think the bell's going to ring. X plus 8, x minus 8. Well, we said that you would just do, sorry about that, you would just do the first one squared, so that's x squared, second one squared, so that's 64, and you put a minus. Okay, let's see how we did. Well, bam. Okay, same with the second one. First thing squared, 9x squared. Second thing squared, put a minus. Let's see how we did. There we go. All right, so again, a little bit easier on this one. So y'all feel free to try these on your own. Should take you like 10 seconds. I'm going to go ahead and keep talking and working them out, but if you'd like to pause it and then come back, feel free. Okay, so I'm going to square the first thing, so 16x squared. Square the second thing, 81. Put a minus. last one, square the first thing. Now this one might be kind of weird to you because it's a negative, but remember, a negative times a negative is going to be a positive. So I've got x squared, square the second one, 49, with a subtraction. And those are your two answers. Alrighty, that's all I have for the notes, as you can tell, obviously, but just try not to confuse the two. I think that is the biggest mistake people make here, is that they just kind of start mixing all the rules together. I try to just remind my students, long problem, short answer, short problem, long answer, okay? The homework isn't on a piece of paper. It is actually online, and I used to have this up here when I did it in class, and people would scan the QR code, but now it's actually in Schoology. So if you log on to Schoology, and I don't think I have it pulled up here. Oh, that's really bad. Okay, I don't have it pulled up. Oh, yes I do. Here we go. Okay, if you look right here in Schoology, I don't know if I can write on this. Oh, I can. The number 4 here, special products, if you click on that, you'll find a link to a website. And you will just scroll all the way down to the bottom, and there will be 10 questions. And you're going to work through those 10 questions, and then just take a screenshot of your final score. It should say 10 out of 10 or 9 out of 10 or whatever. It's okay if you get every single one of them wrong. Hopefully you do not. Hopefully you learn from your mistakes as you go through. But I just want to see that you actually attempted the 10. So take a screenshot after you've done the 10 questions, and that's what you'll bring me tomorrow for proof that you did your homework. If you have any questions, feel free to